In this video, we're going to talk about solving quadratic and rational inequalities. So first of all, we have an example here of a quadratic inequality. Now first of all, this is called quadratic because of the polynomial on the left-hand side there, the x squared. So anytime you see something like, x squared plus 2x plus 4, or 5x squared, or 3x squared plus 2, these are all examples of quadratic polynomials. We also have things called linear polynomials. And linear polynomials are where the degree is only 1, like 5x plus 2, or x minus 5, or x. Now we'll even classify a constant like 3 as linear as well for what we're doing now. Okay, so quadratic means you see x squared, and that's the highest degree, and linear means that the highest degree is x raised to the first power. So this would be classified as a quadratic inequality. So we're going to do two things. The first thing we're going to do is we're going to make sure that the right-hand side is equal to 0. Okay, so that'll be the first thing we do up here. The second thing we're going to do is we're going to write the left-hand side of the inequality. We're going to make sure that it's a product, that means multiplication, or a quotient of what? Of linear factors. Okay, so the first thing, set the right-hand side equal to 0, and the second thing, make sure that the left-hand side is either a product, meaning multiplication, or a quotient, that is division, and here's the important part, of linear factors. Okay, so we're going to see why we want to do these two steps and why it's the first part of a strategy for solving these types of inequalities. Okay, let's take our first one. X squared plus x is less than 6. X squared plus x. So x squared plus x is less than 6. Okay, so first step, we're going to get the right-hand side equal to 0. So it's going to be x squared plus x minus 6 is less than 0. Okay, second step, get this left-hand side to be either a product or a quotient. Okay, well, clearly it's going to be a product, in this case, of linear factors. That basically means factor this. So the way we factor this is just the usual method, the way we factor quadratics. So it's going to be x plus 3 and x minus 2. Okay, so we're good so far, right? The right-hand side is 0, and the left-hand side is a product. See the multiplication right there? And this factor is linear, and so is that one. Okay, next step, what you do is you identify where each of these linear factors is 0. So for example, this factor is 0 when x is 2, right? So this one is 0 when x is 2. And this one is going to be 0 when x is equal to what? Well, it looks like negative 3. You then take both of those numbers, negative 3 and 2, and you put them on a number line. So let's do that over here. Okay, on the number line, we want to locate negative 3 and positive 2. And at this stage, notice that I've created 3 intervals. The first interval is all the numbers greater than 2. The second interval, everything between negative 3 and 2. And the third interval would be everything less than negative 3. Now what we're going to do is we're going to take points in each of these intervals. So pick a point in here, pick a point in here, and pick a point in there. And we're one at a time going to plug them in to both of these factors. For example, take a number in this interval. So can you think of a number less than negative 3? Sure, right? Take like negative 4, for example. Take negative 4 and plug it in where you see x, both there and there. Okay, so I say, what do I get? When x is negative 4, this becomes, well, negative 4 plus 3 times negative 4 minus 2. And what do I get? Well, this is negative 1 times negative 6, but the important point is that it's, well, a positive 6. Okay, so a negative times a negative is a positive, and 6 is greater than 0. Now, for that reason, because I got a positive when I plugged in negative 4, What I'm going to do is I'm going to go to this interval over here, and I'm going to put a little positive sign. So you put a little positive sign when you plug in your little test point and you get a positive. Okay, let's try another one over here. So between -3 and 2, pick a test point. So pick like the number 1, for example. So I'm going to take the number 1 and I'm going to plug it in right there, and I'm going to plug it in right there. Let's do that mentally. So 1 plus 3 is 4, and 1 minus 2 is -1, and 4 times -1 is a -4. Now what matters is that it's negative. We're just keeping track of the signs here. I got a 6 before, so I put a positive. I got a -1 just now, I put a negative. Now let's pick a test point like, anything greater than 2. How about 4? So plug in 4. 4 plus 3 is 7. 4 minus 2 is 2. And 7 times 2 is positive, right? It's positive 14. So I put a little positive right there. Okay, now what have I been doing? This little, positive, negative, positive, that refers to what I got when I plugged into x plus 3 times x minus 2, right? So this here, x plus 3 times x minus 2, I figured out where it was positive, where it was negative, and again where it was positive. And then I look at the original problem. What did it say? Well, when is that product, right, the product, when is it less than 0? But less than 0 means negative, and I can see it's negative right there, right? That negative sign means less than 0. And so all the numbers between -3 and 2 are solutions. Why? Because when I plug them in, I get a negative. That's what the little indicator 1 told me. The little indicator 1 spoke for all the numbers between -3 and 2. When I plugged in any number in that interval, I get a negative. Okay? So that means my solution set, that is my solution to this problem, is just all the numbers between -3 and 2. And that's it. Now you might say, well, why don't you want other numbers? Well, you don't want numbers larger than 2 because look, the product is positive, and less than -3, the product is positive as well. Okay, so those are the steps to solving a quadratic inequality. Make sure the right-hand side is equal to 0, and the left-hand side, make sure it's a product of linear factors. Okay, let's try another example, kind of like quadratic inequalities. So this next one will be very similar. Let's go ahead and solve. Let's go with, how about 1 divided by x plus 2 is greater than 1 over x. Now, this problem actually is what's classified as a rational inequality. So that's a rational inequality. And it turns out rational inequalities and quadratic inequalities are handled very similarly. So first of all, let me point out one thing that we cannot do. In this case, I can't clear fractions, right? I can't multiply both sides by x times x plus 2, like I would have done if this was an equation. And the reason is because, let's say I do that. Let's say I multiply both sides by the LCD. Well, the LCD will contain the variable x. And the question is x positive or negative? And the answer is we don't know at this stage, so I don't know what to do with this sign. If x is positive, or if the LCD is positive, I would leave this as greater than. And if it was negative, I would have to flip the sign. Because you don't know if you're multiplying by a positive or negative, you never clear the LCD when you have a rational inequality, okay? Or you never try to clear fractions by multiplying both sides by the LCD. So you never clear fractions when you have a rational inequality. Okay, so what do we do instead? Well, you handle it just like we did the previous one. That is, you get 0 on the right-hand side first. So we've got 1 divided by x plus 2, and it's going to be minus 1 over x is greater than 0. Okay, the next step is write the left-hand side as either a product or a quotient of linear factors. Well, in this case, it's going to be a quotient. So we're going to combine these two rational expressions. So the LCD is going to be, or the LCD is, x multiplied by x plus 2. So I need to multiply top and bottom of this by x. So times x, and top and bottom of this one by x plus 2. So here we go. So this is going to become, let's see, x divided by, and we'll leave this factored as x times x plus 2. And the next one's going to be minus, well, we have parentheses, x plus 2 times 1, and the denominator is x times x plus 2. And that's greater than 0. Okay, now these have the same denominator, so let's combine the numerators. And you have to distribute that -1 right there because this is a sum. So it's going to be x minus 2 divided by x times x plus 2, and that's greater than 0. Okay, the numerator is now -2 divided by x times x plus 2, and it's greater than 0. Okay, notice where we're at. The right-hand side is equal to 0, and the left-hand side is a quotient of linear factors, right? Linear, x raised to the first power, linear, x raised to the first power, and just a constant. Okay, so just like before, what you do is you locate the numbers that cause the factors to be 0. This factor is 0 when x is 0, and this factor is 0 when x is equal to -2. That factor, that is the numerator, is never equal to 0. So I'm going to put -2 and 0 on a number line, just like before. So let's do that. So we've got -2, and we've got 0. And just like before, we're going to pick test points. So pick a number in this interval, like -3. Okay, now plug -3 in for x and see what you get on the left-hand side. So we're asking ourselves, hey, what happens to -2 over x times x plus 2 when you plug in these test points? Well, let's see, with a -3 here, it's negative, and -3 plus 2 is a -1, and a -3 times a -1 is positive, but this makes it negative. Why? Because a negative divided by a positive is going to be a negative. And now you see why we are getting the left-hand side to be a product or a quotient, right? Because you know the sign of the left-hand side simply by knowing the sign of the factors, right? So let's recap that. For -3, this is negative, obviously. -2 is always negative. That was negative, and this was negative. So a negative divided by, well, a negative times a negative is a positive. A negative divided by a positive was a negative. Now let's plug in -1. So if you plug in -1, what do you get? Well, -1 is negative. -1 plus 2 is a positive. A negative times a positive is a negative, but this negative makes the whole thing positive. That's right. Go on to greater than 0. Pick like a test point of maybe 1. So this is negative. 1 is positive. 1 plus 2 is positive. And a negative divided by a positive is a negative. So we go back to our original problem. The original problem said, when is that whole thing greater than 0? And I can see, right, greater than 0 in this interval right here. So my solution is all the numbers between -2 and 0. That is this interval. Okay, so that's how you solve rational and quadratic inequalities. You make the right-hand side equal to 0, and make sure the left-hand side is a product or a quotient of linear factors. Put the numbers that cause the factors to be 0 on the number line, and assess what happens in the corresponding intervals. And then interpret those signs. Okay, that's it.